All right, we're going to take a look at exponential growth and decay. And at first, I know this is going to make you want to run for the hills, but just kind of hang in there. Once you see how simple these are, you'll be okay. All right, so the biggest thing is you just need to highlight or underline or circle important things that you need. So let me show you how to do that. A town's population is currently 500, so I need to know that. The population is currently 500. So I'm going to go ahead and underline or circle that because I need that. It says if the population doubles. So before I read any further, what does doubles mean? Double means I'm going to multiply by what? By 2. So it's going to double every 20 years. So it's going to be multiplying by 2 every 20 years. What will be the population 80 years from now? Okay, so you start off at 500, and it's going to double, multiply by 2, every 20 years. So it's not, I'm not multiplying it by 2 because that'll be for 80 years. It's only for 20 years. So how many 20s will get me to 80? 4. And the way I find that number is if you do what you want, the total of years that you want over how many years is given, you're going to get that number, which is 4. So 20 years and another 20 years, so 20 and another 20 and another 20 and another 20 will give me the 80. So how many times am I going to multiply by 2? 1, 2, 3, 4. So I could either write that as I'm multiplying by 2 4 times, or what is another way I can write this a little bit faster? I'll give you a hint, it's exponents. So I'm going to write 500 times 2 to the power of 1, 2, 3, 4. And that's what you put in your calculator. Okay, so your starting population, it's going to double every 20 years, which means it will double 4 times. So what you do is you take your calculator and you're just going to punch it exactly as how you see it. So it's going to be 500 times 2 to the power, and this button right here gives you power. So to the power of 4, which is 8,000. So your population is 8,000. Brilliant. All right. So again, this is just what we're going to do for all the word problems. All right. The half-life. So again, if it's talking about half-life, okay, you're talking about decay. All right, pull out what the information they give you. So it says the radioactive kind of an antimony, and I can't read just like you all, is 3 years. Okay, so I need that. The half-life is 3 years. That's what that's saying. How much will be left after 9 years? So how much will be left after 9 years if you start with 96? So write down the formula. Okay, remember half-life is just half. It's just like the other formula is just half. That's all you have to remember, okay? So write down the formula. So P equals 0.5 T. And remember, T, okay, is the number of half-lives given in the period. And how do you find that? By taking the total number of years, which is total, which will be left after 9 years, over the half-life number of years, which is 3. So that's what T is. So I'm going to rewrite this. Oh, I'm sorry, the equation's wrong. P equal, there you go. That's the equation. So I'm going to rewrite this with just the numbers. So the P stands for the original amount. So what was the original amount? It was 96 grams. And then we have 0.5, and then we have T, which is 9/3. And you don't even have to simplify this before you put it in the calculator. You're just going to put it exactly how you see it. So you're going to go 96, open parentheses, 0.5, close parentheses, and then remember to put it to, raise it to the power, you put this button right here. And then anytime you have a fraction, you do what? Put it in parentheses. So what's that fraction? 9 divided by 3, close parentheses, enter. So 12. So you'll be left with 12 grams after 9 years. That's what that question is saying. Fantastic. All right, a city doubles. What does double mean again? Multiply by 2. Its size every 8 years. All right, every 8 years, it's doubling by 2. So in 8 years past, multiply by 2. Another 8 years, multiply by 2. If the population is currently, so this is my start, so 250,000, what will be the population in 32 years? So remember, it's saying take the population, double it, every what? 8 years. So I need to know how many times I'm doubling it if I'm going for 32 years. Well, to figure that out, I'm going to do 32 divided by 8 because it'll tell me how many 8 years will be in 32. So you just 32 divided by 8, and that's going to give me 4. So they're going to be 8 years in 32 years. That means I'm going to double it 4 times. So instead of me writing doubling it 4 times, I can do that in exponents and say 2 is the base, and how many 2's do I have? 4. And then after that, you just simply put in that into the calculator. So you're doing 250,000 times 2 raised to the power, okay, and that's this arrow right here, raised to the power of 4, which is 4 million. Perfect. All right, so again, this is a half-life. So immediately I write down the half-life equation. And again, if you forgot how to do this, you can just look at your notes. All right, so the equation is y equals p 0.5 t, where t is the total time, I guess total over the partial, over your half-life. Okay, and then all you're gonna do is you fill in the numbers. So you have 880 grams. What is that? That's my initial amount. So that's going to be my P, 880 grams. Then you have 0.5. And then T is the total. So if the half-life is 14, so half-life is going to be underneath. So that's 14 underneath. How much will be left after 42 days? Now be careful, okay? Because sometimes they trick you. This is days and this is days. If it wasn't both days, you'd have to convert it to be the same unit. But because they are, that's fine. So 42 over 14. And then you just put that in the calculator. You don't even need to simplify because the calculator will do it for you. All right, so we're going to put 880 parentheses, 0.5, close parentheses, raised. So remember, this is raised. And then anytime you have a fraction, make sure you put it in parentheses. 42 divided by 14. So 110. Fantastic. All right, the word problems may be getting a little longer, but it doesn't matter. You're just going to get the information that you need. Martha's website has been getting more popular, primary word of mouth, blah, blah, blah. I don't need that whole sentence. I don't care. Each month she sees a 10% increase. I do need that. Okay, so anytime you see numbers, you definitely need that. 10% every month. Okay, so every month she sees 10% increase. If Marsha's site had 22,000, so this is what she started off with. This month, how many pages can she expect 3 months from now? So what's happening? It's increasing. Is that growth or decay? That is growth. So you go into your growth formula, and again, remember that this is given to you, right? So this is the one for growth or decay. This is the rate of growth or decay. So this is your generalized formula. You just need to remember for growth, you're going to write it as a decimal and going to add 1 to it. For decay, you're going to write it as a decimal and subtract it from 1, okay? So since we're talking about growth, our B is just going to be 1 plus our percent as a decimal. So you write out your equation, okay? So y equals A, B, X. And because we're talking about growth, that B is going to be 1 plus your percent as a decimal. All right, and then all you do is just punching in the numbers. So I need my initial amount, so go find my initial amount. So I've highlighted or circled things that I need. I got 10% increase. I got 22,000 3 months from now. So Martha's site had 22,000 page views this month. That's her initial. So that's going to be 22,000. That's my initial. My B is going to be as a add 1 to the growth as a decimal. So I've got a 10% increase. And remember, to make a percent into a decimal, all you have to do is divide it by 100. So 10 divided by 100 is going to give me my increase. So this is going to be 1 plus 10 over 100. All right, to the value of X, which is the time that has passed. So what's the time? So 3 months from now, so that's the time. And all you do is you punch that into a calculator. Just remember that anytime you have a fraction, you need to put parentheses. So let's go ahead and type that in. So you're going to have 22,000, open parentheses, 1 plus. And then because it's a fraction, I'm going to put it in parentheses. 10 divided by 100. Close the parentheses I just opened. And then this is the next parentheses. To the power of, so again, this is power button right here, power of, and 3. And your answer is 29282. So that's how many page views that you will have. Fantastic. Okay, so it doesn't matter like what the word problem is, just go through it. All right, so again, a town's population is currently, so this is the initial. If the population doubles, so what does double mean again? Times 2. Every 5 years. What will be the population 20 years from now? So again, remember they're saying you start off with 4350, right? You're going to multiply by 2 because you're doubling it every 5 years. Okay, but they're asking what will the population be 20 years from now? So you're going to double it every 5 years. So I'm going to double it the first 5 years, double it the second 5 years, double it the third 5 years, double it the fourth 5 years. Okay, so you need to find out how many 5 years are going to be in 20. To find that out, all you do is you take your total divided by a partial, and that will give you 4. They're going to be 4 5 years in 20. That makes sense. 5, 10, 15, 20. So they're going to be 4 5 years in 20. So you're going to double it 4 times. So you can just take this number and double it 4 times, or you can put this as an exponent. These are all the base, and how many do you have? 4. And you just put that into the calculator. So it's going to be 4350 times 2 raised to the 4th power. So it's 69,600. A town doubles. Again, what does the word doubles mean? Multiplied by 2. If it was triples, it would be multiplied by 3. If it was quadruple, it would be multiplied by 4. So it doubles every 28 years. The population is that, so the population is 1480. What will be the population in 56 years? So how many 28s are in 56? To find that, you just do 56 divided by 28. 56 divided by 28, and you get 2. All right, so it will double twice. So I will be multiplying it by 2 times. And all you do is you punch it in the calculator. 1480 times 2 raised to the power of 2. 5920. Okay, and you'll notice that as you get the hang of it, you're going to get faster. Again, here's your population. It doubles. What does that mean? You multiply by 2. Every 34 years, what's the population 68 years from now? So you start off with 1640. You're going to double it how many times? How many times is 34 going to 68? So you're going to do 68 divided by 34, which is going to give you 2. So it goes 2 times. So you're going to double it twice, and you just put that in the calculator. So 1640 times 2 raised to the power of 2. So 6560. All right, a town doubles its size. So again, we're doubling, so what's that? Multiplying by 2. Every 41 years, the population is 2941, and we're doubling it every 41 years. What's the population in 82 years? So how many 41s are in 82? To find that out, you're just going to do 82 divided by 41. It's going to give you 2. So you're going to double it 2 times. That's what that's saying. So you're going to double it 2 times. So you'd either go 2941 times 2 times 2. That's what doubling twice means. Or you can do it as exponents, 2941 times 2 raised twice, because that's what that's saying. That's going to be 2 times. That's what the same thing. So you'll get the same number. So 11764. All right. You have, what am I looking for here? I see the keyword, which is half-life. So I get out my notes. I look up my formula for half-life, write my formula down. So y equals P, which is my starting principle, 0.5, T, where T is the total divided by half-life, okay? Total divided by half-life. And I just fill in the information. So my initial amount, so y equals my initial. You have that grams of radium, that's what you have. So that's my initial amount, 93464. Then 0.5, and then my time. So I need my total over half-life. How much will be left after 4 minutes if the half-life is 2? So my total is 4 because it says my half-life is 2. And you're just punching that into the calculator. So 93464, open parentheses. So I'm just typing exactly what I see. 0.5, close my parentheses. And then 4 over 2. So raised, so again, this is to raise. And then because it's a fraction, don't forget, you always put fractions in parentheses. So 4 divided by 2, close parentheses. So 23366. All right. All right, Martha lives in Lexington, where the cost of living increases by da-da-da. Martha spends blah, blah, blah. She goes da-da-da, maintain the same cost of living. All right, so I see the word increasing. So since we're talking about exponential growth and decay, I'm obviously talking about growth. So here's my equation, which they give you on the reference sheet. And my growth is, just remember that you add 1 plus percent as a decimal as the b. So write it down. So you write down y equals ABX, where remember this is growth or decay. If it's growth, it's 1 plus percent as decimal. If it's decay, it's 1 minus percent as decimal. And you just fill in the information. So you have y equals, A is your starting amount. So what do I start with? So let's read. Or just let's fill in the information in order. Cost of living increases by 10%. So that's my increase. So percent as a decimal is that. So over here, it's going to be 1 plus. And how do I write percent as a decimal? I divide by 100. So whatever it is, so it's just 10 divided by 100. That's what that is. So that's that. If Martha spends this is what she's spending. Okay, so that's what she initially is going to spend. So that's 93600. So that's my initial spend. How much can she expect 16 years from now? Years is time. So 16 goes there with the time. And then you just put that into the calculator. So it starts off with the initial, which is 93600, and then times, open parentheses, then it's 1 plus, and anytime you see a fraction, you put it in what? Parentheses. So parentheses, and it says 10 divided by 100, close parentheses, and then there's this one where you close it, and then raised to the power, so remember this is raised to the power of 16. Round your answer to the nearest cent. So I have 430089. All right, point. Now cents. Remember that 2 cents, like 25 cents. There are 2 numbers after the decimal. So I'm going to look at my 2 numbers. So 4717, that's after the decimal. 2 numbers after the decimal. What does this one do? Nothing. So it stays as 0.47. So 0.47. All right. I'm finding my keywords. I'm finding increasing. So this has got to do with growth. So again, you're going to write your formula down just like my previous question, which is this, where B is 1, because it's growth, 1 plus. If it was decay, it would be y minus percent as decimal. And you just fill in your numbers. It's your principal, that's your time. So now I'm just going to fill in my numbers, just in order. Video posted is becoming popular, I don't care. And a total number of views is increasing by 16% every hour. So that's my percent. How do I make my percent into a decimal? Just divide by 100. So that's going to be my parentheses, 1 plus 16 divided by 100, because it has to be a decimal. If the video is currently at this views, so this is my initial number of views, 71900. How many views will you have in 7 hours? So my time is 7. And all you do is you take that and you put it into the calculator. So you have 71900, open parentheses, 1 plus 16. Oh, because it's a fraction, I'm sorry, you always put it in parentheses, 16 divided by 100. Close the parentheses I just opened, and then there's a close this one. Raised, so that's this, raised to the power of 7. So you're going to get 203,205 point to the nearest cent. So after the decimal is 1989. So cent, like if you have 25 cents, is 2 numbers. What does that 8 do? Makes that go up to by 1, that goes up to 0, and that goes up to 2. So 0.20. Oh, look at me, I didn't read it. It said the nearest whole number. Okay, so let's read the question. All right, a pan from the oven set at cool temperature. The temperature difference between the pan and room temperature is currently 120 and decreasing. So what does decreasing mean? Decay. So you get your formula sheet out again. So this is the general formula, where B for growth is 1 plus the percent, and for decay it's 1 minus the percent. So we're going to do 1 minus this time, so write it down. So you're going to do y equals ABX, where this, because it's decay, is 1 minus percent as a decimal. and then you just fill in the information. So a pan, blah, 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 cool at room temperature. I do not need that at all. The temperature difference between a pan and room temperature is currently 128. So the temperature is currently, so if it's currently that, what do you think that is? That's your starting. So my starting is 128, and then I'm going to have 1 minus percent, which again, to make anything into a percent, you just divide by 100. Okay, so it's decreasing. That's how I know I'm subtracting. All right, at 6%. So that's my 6%. Every minute, how much above room temperature will the pan be in 9 minutes? Minutes is my time, and that's my x, so that's going to be 9 right there. Then you just punch that into the calculator as you see it. So it's going to be 128, open parentheses, then 1 minus, anytime you see a fraction, you do what? You put it in parentheses, so 6 divided by 100. All right, and then close parentheses, raised to the power of 9. Again, this button right here is raised to the power of 9. And you press enter. All right, so it's 73 point, and this says, I didn't read it on the last question, so please make sure you read in the question, round your answer to the nearest tenth. So tenth, all right, so if it's 10, it's 1 0, so 1 number after the decimal. If it's 100, 2 zeros, 2 numbers after the decimal. If it's 1,000, 3 numbers after the decimal. So because this is 10, 1 number after the decimal. So I write down 0.3433. 1 number after the decimal, 1 number after decimal. You look at this next number, what's it going to do? Nothing, so it's going to stay 0.3. All right, we're talking about half-life. So again, you go to your half-life formula. So, bam, you start off with your half-life formula. So, pardon me, my phone fell. All right, so my half-life formula, let me get this back. So my half-life formula is y equals p, as in the starting, 0.5, because it's half-life, half, and then t, where t is how many periods are in that time period, okay? So half-life radioactive, the half-life is 2 minutes, so that has to do with the time. So remember, t is your total over your half-life. So 0.5, t is my total over my half-life, and my half-life is 2. How much will be after 4 minutes? So that's my total, 4. If you start is my principal. What I'm starting with is 53744. Okay, once you have that, you just punch it into the calculator as you see it. So it's going to be 53744, open parentheses, 0.5, close parentheses, and then raised, so as an exponent, that's this one. And anytime you have a fraction, you always do it what? Put it in parentheses, so 4 divided by 2. So 13436. All right, again, just skim through it. I see half-life, so that's my formula for half-life, which we just wrote down. Y equals P 0.5 T, where T is your total over your half-life. All right, and then just fill in the numbers. How much radioactive helium will be left after 210 minutes? So that's your total. So it's going to be 210 minutes over half-life, which is 70, 0.5, and I just need the principal, what I start with, and I start with 493,600. Okay, and punch that in the calculator, 493,600, open parentheses, 0.5, close parentheses, and then raised, so that's this button right here, raised, and anytime you have a fraction, you put it in parentheses, 210 divided by 70. So 61700. Again, this is another half-life, okay, and you can kind of just skim through it and see if they're asking for growth, decay, compound interest, but they're asking for half-life. So half-life, you write down the formula, y equals P 0.5 T, where T is your total over your half-life. All right, fill in the information. How much after 103 hours, and this hours is a key that it's time. Okay, so if you have minutes, seconds, hours, that's obviously time. So it's got to do with the T. So that must be left after 108, and that doesn't say half-life, so that's my total. So you're going to have, your total is 108 over half-life, which is 36 hours. So that's still got to do with T, and that's my half-life. So that's going to be 36 hours, 0.5. And then what's my P? I start with 577.04. And then you just punch that in the calculator. And honestly, once you punch it in once, I can just go back and change it, but I won't show you how to do that right now. 570.704. Oh, oops, I'm not typing anything. 570.704, open parentheses, 0.5, close parentheses, raised to this power. So again, you press that. And anytime you have a fraction, you put it in parentheses. So 108 divided by 36. And you have 71338. All right. Okay, raises. Raises. What does raises mean? Is that growth or decay? So that's going to be growth, right? Because it raises. If it was decreases, then it would be, or declines, that would be decay. So I obviously need my formula for growth. So again, your general formula is that. And if it is growth, you're adding 1 plus percent. If it's decay, you're 1 minus your percent. So you write down your formula. So y equals a, b, x, where your b is 1 because it's growth, 1 plus percent as decimal. Okay, so fill in your information. So it's expected to negotiate for its members to get a 6% increase. So again, B is going to be 1 plus that as a decimal. And how do I turn anything into a decimal? I divide it by 100. Okay, so that's what that is. If a union member is currently a salary, currently means what you're starting with. So that's my beginning. So that's going to be 92480. What would be salary in 4 years? Years is what? Time. So time, that's X, 4. Okay, so then you just punch that in. So 92480, open parentheses, 1 plus, and anytime you see a fraction, what do? You put it in parentheses. So 6 divided by 100. Close my parentheses I just opened, and then close the one that was originally there. Raised to the power of 4. So you go raised to the power of 4. So you're going to get 116,753. And my decimal is 8693. So you read how they want you to round to the nearest cent. So the nearest cent, so you have 25 cents. So that means there are 2 numbers after the decimal. So then you look at that number. What's that going to do? Make it go up by 1. So it'll be 87. So my answer will be 0.87. All right, a colony doubles. So again, remember what is doubles? Multiply by 2. So you start off with 4, 5, 4, 6, and you're multiplying it by 2 every 171 minutes. What is the population after 684 minutes? So I need to know how many times am I going to double it. So how many times does 171 go into 684? So 684 divided by 171. It's going to happen 4 times. So I'm going to double it 4 times. So I can double it 4 times, or a faster way to write this would be 2 to the power of 4. Okay, so 4, 5, 6 times 2 to the power of 4, or you could just do that whole thing. I'm going to do the shortcut. So 4, 5, 4, 6 times 2 to the power, because I'm going to double it 4 times. It's going to be 72736. A scientist, blah, 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 blah. It is increasing. So what are we talking about? We're talking about growth. So it's going to be 1 plus. So again, you write down the formula. So y equals a, b, x, where this is growth is going to be 1 plus percent as a decimal. If it was decay, it'd be 1 minus. And then fill in the information. So blah, 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 blah. The city's population is increasing by 10%. So that's my B. So 1 plus, and how do I make a percent into a decimal? Divided by 100. So 10 divided by 100. And there's currently there's that. So currently is 51449. And what population will it be in 12 years? So in 12 years, that's my time. And then you just punch that into the calculator. So you have 51449, open parentheses, 1 plus, and then anytime you have anything as a fraction, you put it in parentheses. It's going to be 10 divided by 100, close parentheses, and then it's close parentheses. So there'll initially be 2 close parentheses, basically. Raised to the power of 12. So raised to the power of 12. So 161, 469, 469 point, and my last ones are 0.0016 after the decimal, right? Oh, you can't see that, so there you go, 0016. Round to the nearest whole number. Whole number means nothing after the decimal, so decimal will be my cutoff point, and what's the 0 gonna do? Nothing, so it's gonna stay exactly the same. All right, we'll take a look at one more. All right, let me see if I can find the word, either half-life, increasing, decreasing, anything like that. According to current caffeine is broken down. So if something is broken down, is that increasing or decreasing? That's decreasing. So again, you look at your general formula. And then you're decreasing. So y equals ABX, and you're decreasing. Remember, increasing is 1 plus, but decreasing is 1 minus as a percent. Now let's fill in our information. Scientists is creating a mathematical model for breakdown of coffee in the human body. I don't care that you're doing all that. According to your current model, caffeine is broken down at a rate of 14%. So that's how much it's decreasing. So that's going to be involving my B. So 1 minus. And how do I write 14% as a decimal? Because this is as decimal. I do 14 divided by 100. So I've used that. If a person consumes a sample containing 56 milligrams, so that's what you're starting off with, so 56, that's your A, how much will remain in 3 hours? And that, again, your key thing is hours is time. Hours, seconds, days, all that is time, so that's going to be X. If you're ever confused as to which one is which. All right, then just punch that into the calculator. So you're going to have 56, open parentheses, 1 minus. Anytime you have a fraction, you're going to use parentheses. So 14 divided by 100, close parentheses. And then now you have this parenthesis that you're going to close, raised to the power. So raised to the power of 3. So 35. And then my decimal part is 619,136. Now let's read what the question says. It says the nearest tenth. So the nearest tenth is 1 number after the decimal. So 1 number after the decimal, what does that 1 do? Nothing. So it's just going to be 0.6. Okay, and that's pretty much what you have to do. I'm just going to do one more problem. You're contemplating the impact of blah, 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 breakdown. Breakdown means decreasing. So you write down the formula, the general formula, which is given to you, where it's decreasing, it's going to be 1 minus % as decimal. And then you just fill in the information. So a patient will take, so you're going to take this. That's going to be my starting. But even if you didn't know that was your starting, you fill in everything else, and then you'll see what it is. So you're going to take this every hour, and his body's going to break down that. So that's going to be my B. It's going to be breaking down. How do I turn % into a decimal? Divided by 100. How much will be left after 9 hours? Hours is time. So the only number would be left would have to be what you start off with. And then you just punch that into the calculator. So 578, open parentheses, 1 minus, and then open parentheses, because it's a fraction, 35 divided by 100, close parentheses, and then you close this parentheses, raised to the power of 9. So you're going to get 11, and then after that it's going to be 0.9714, blah, 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 to the nearest tenth. So 1 number after the decimal, what does a 7 do? Makes that go up by 1. So that goes up to 0 and carries up to that one, so it's going to be 12.0.